Hi guys, this is a quick video that I want to make to recap the 4 periodic trends that we discussed. I realized looking back there were some goof ups in the notes and things like that, and maybe it was not my best work. And so I just want to provide just a quick little video and some extra practice for you guys if you're wanting some extra help to work through our trends. So there's 4 trends that we discussed: atomic radius, ionic radius, electronegativity, and ionization energy. And so atomic radius goes into the size of it. So here I'm going to go ahead and label this as my periodic table that I'm going to show that trend. So atomic. And then this is also going to be my ionic radius on this one. So I can show atomic radius. I'm going to use this pink color. And then ionic radius, I'll use like this green. And so what happens is, in terms of size, what direction it increases in. So the atom gets largest here where francium is found. And the reason why is when you move down a family, the atom gets larger. Doesn't matter which side of the periodic table you're on, the atom at the bottom is larger than the one above it. And it's because it has more energy levels and electrons are further away. It gets larger as you go to the left because this, like fluorine, has more protons than lithium. And so these 9 positive protons are going to have a greater pull on the electrons than the 3 protons lithium has. So the summary of atomic radius is it gets bigger to the left and down the family. Ionic radius essentially works the same, that an ion found to the left and down is also going to be bigger in size. So those follow the same trend, which is handy. So the other trend that we discuss, or other 2 trends I should really say, is electronegativity. And so that is the ability to attract electrons, and that's to get to the point of having a full shell. So the one thing I am going to do is I'm going to kind of gray out here the noble gases for electronegativity, or actually, I don't want to do that because I'm going to have another trend on here. So electronegativity, I'll just write below it, does not include group 18, the noble gases, because they're not looking to obtain electrons. They have a full valence shell. And so when we look at comparison, is the smaller the atom, the greater the electronegativity. So for that trend, I'll use kind of this pink color here. And so the trend here is that as you move up and to the right, the atom becomes more electronegative, excluding the noble gases. And that's because these elements are smaller in size, and they are desperately, because of that small size, wanting to obtain that last electron to get to the point of being full. The last trend we talked about is ionization energy, which also deals with electrons. The difference is ionization energy is looking at how much energy does it need to take away electrons. So electronegativity is kind of like I think of it like a magnet. How big is the magnet for attraction for electrons? Ionization energy is kind of like tug of war on how much of a fight is that element going to put up giving away that electron. So ionization energy I'll do here in this blue color, and it follows the same pattern, that as you go up and to the right, electronegativity gets greater. So fluorine desperately is trying to seek out an electron, and it's also very difficult to remove an electron. It's saying francium here would have the lowest electronegativity and ionization energy. So A, it's not looking to obtain more electrons as desperately as fluorine. And if it lost an electron, because those electrons are so far out from the nucleus, because it's so large, it really doesn't care. So that's a quick synopsis of our trends. Here is just an extra practice. This is not being taken for any kind of points. It's more for you, and you can reach out and ask questions. I'll post an answer key as well if you want to check answers and those types of things. But here it says circle the element that has the larger radius. So you have 2 here to pick from, aluminum or boron. So we're looking for larger. here's aluminum, here's boron. We can see that as you move down the family, it gets larger, therefore aluminum is going to be greater in size. So then like here, it's asking which one has a greater ionization energy, lithium or fluorine. So when we look here, here's lithium, here's fluorine. Fluorine is desperately going to not want to give away an electron compared to lithium, so fluorine is going to be greater. So that's what you're looking at here with the trends assignment. Like I said, I can post a final answer key with this post as well. If you still have questions with trends, feel free to reach out to me.